All right. Welcome everyone back from lunch. The next talk is from Devdas Bhagat. But before he starts, I will have to inform you about the Thomas Cran competition, or the SSDs, or you can still attend to the SSDs winning situation till 16:30. So yeah, if someone wants to win a SSD, he had to still have the chance to. So yeah, that's all the information. Let's have fun.
All right. So this nice little quote, I have a test network, came up at DevOps Days Amsterdam while me and Andreas, we were working together at Booking at that time. And we ended up going and saying, well, we were joking around at the back of a room because it was a testing talk and people were speaking about, oh, you need to have all this stuff, unit tests and production and pre-production. And we were like, we don't do any of that. And it turns out we have better uptime than this other company does. So that's where this whole thing came from. And we're like, there must be something. So the hard part in any business is big data brings it really to the fore. And as you mentioned earlier, if you have a lot of metrics, you need to figure out what the right questions to ask are. Because you have all the data, now you need to figure out what to do with it. Well, you have correlations, what can you do? Is this an anomaly? Is this normal? Is this dependent behavior? Who the hell knows, right? There's simply too much data to ask. So hard questions in business, what do you know? Do I know why customers are buying? Do I know that something is being sold, or do I not know that it's being sold? How much visibility do I have into my production environment? Especially in terms of if you think, what does the business care about? What does your CFO care about? What does your CEO care about? Nobody cares about metrics like CPU load, disk usage. They do care if things go down, but as long as those things are up and in budget, it doesn't matter. You write software to deliver a service. It is not, nobody's writing software just for the sake of writing software, right? Well, unless you're doing it as a hobby, in which case more power to you. Then the harder one is, what do you not know? So, well, everybody has blind spots. You don't know why people are doing stuff. You don't know if you change something, what will happen. We know that we have a system that kind of is lurching along, but hey, who the hell knows why it is lurching along? Can we make it better? Can we make it worse? And then the Achilles heel is, what do you not know that you don't know? Because this is going to come and kill you, and you have no clue what it was. At one point, hosting companies were big. Then there was this little company called Amazon which started its virtualization thing, and everybody laughed at it. And today, hardware vendors are crying because nobody's really buying their hardware any longer. Everybody's running on Amazon, except some companies like Booking and Spotify, which still buy a lot of hardware. But in terms of sheer numbers, Amazon dominates the market, Amazon, Facebook, Google. And those are simply too big numbers to ignore, and they are big enough to order their own custom hardware. Well, there you go. Suddenly, and the environment has changed, and you don't know what hit you. OpenStack, same issue, I think. Lots of people are still saying they'll use OpenStack, but it's still being driven by vendors, not so much by community. Users are voting with their feet. Another favorite topic for any DevOps Days thing, feedback loops. How fast can you learn? And how quickly can you learn before things blow up? I assume everybody knows that picture. If you don't, that's from the Tacoma Narrows Bridge. That's the classical example I pull out whenever anyone says, why can't we build software like we build buildings or like we build bridges? Well, that's what happens. When you try to do a new kind of bridge, it fails epically. And that was a failure in production. Fast feedback loops give you this nice little thing of being able to test business ideas out. It isn't necessarily limited to saying my development is faster, my operations are better. Hell, test out a business idea. You can say, well, let's see if I put up a thing here that I change the color of my font on my web page, does it help? Does it convert better? Do I put up a Christmas theme for December? When do I put it up? When will it convert better and in what markets? Because if you are an international company, well, it happened, and international as in not just localized to Europe, suddenly Christmas may not be an important festival in some regions. It's like test-driven design, or test-driven development, or whatever you want to call it. Roll out an idea, check, see what users say, come back. How do you know what users are saying? Well, they give you money. It's the biggest it's the biggest final test, right? It doesn't matter how good your software is, if nobody wants to use it, it's dead in the water. If people are willing to use the software regardless of how horrible it looks and how horribly it works, well, there's a market, and you can then start focusing on what will make things better. It enables IT to speak the language of business. You can then go and speak in terms of ROI and financial stuff and monetary metrics instead of saying, oh, code quality, or this will improve, that will improve. Why do you need high availability? Well, if you lose your data center and your business goes down, what happens? You're not necessarily a software company. You're in the business of doing something else, and you need the IT infrastructure to be up and running. What happens if your production database goes down? Well, the factory shuts down. That's a bad thing. And you can translate that into dollar numbers. Translating IT terms into money suddenly makes things very simple, because most people get an idea of what money is. And then you can just say, show me the data. I think this idea is stupid. Yeah, no, let's test it and see. Maybe people like it. There's a popular acronym for this called the HIPPO, the highest paid person's opinion. You do not want a HIPPO opinion going around because it boils down to the manager going, well, I know better than you of what the users want or what your customers want, which is not that he knows anything or she knows anything, just means that they have an opinion and they have the authority to force you to follow it. So as a culture, you can just say, we do not want to follow this. Everybody brings along data. How do you bring along data? Well, let's run a test. Let's run an experiment. It shouldn't take very long to set up a small experiment that says, well, we got 1% of our customers to look at this, and half of them were responded positively, and the other half ignored it. That's a very good, that's a 50% success rate on your test. Extremely good. Or, well, we tried this out and sales dropped through the floor. Bad idea regardless of who put it up, right? So, here's another nice trollish question. What makes software good? Anyone with opinions? So developers have their own metrics. Religious ones, object-oriented, functional, procedural, whatever. It is testable, follows dry. There's a whole bunch of opinions, is maintainable, everybody can read it, whatever. You ask the ops guys, they'll tell you it should be bug-free, scalable, it should be monitorable. I don't want to hear about this software. And I especially do not want it waking me up at night. Right? Should be secure, because security is one of those things that everybody claims to care about. And the business guys go, well, does it make me money? Does it save me money? Two questions. Does it generate value, basically? If your software isn't making you money, it isn't saving you money, well, then why are you running it? I have no idea. Oh, yes. Classical software development lifecycle. Regardless of how many test stages you have, if you're doing a web shop thing or equivalent, this is what it looks like all the time. You can have a test environment, you do stuff in dev, then you test it, you do performance testing, you do acceptance, hits production, real world, software fails. Why? Because no one ever thinks about a few things. Like there are humans doing odd things on the other side of your system. Test environment, very well controlled. Yep. Here's all our repeatable performance tests. Out here in meat space, has anybody managed to do a repeatable test? You can't even cross the same river twice. Ops problem now, or rather it becomes a business problem. Because you may be able to say, well, there's no big thing, but sales are dropping 1%. That's a fair steep drop. How fast is your feedback loop for this? And this is the agile feedback loop, right? Not even the whole, let's do the waterfall model stuff. Your final production release, it involves a release meeting to get feedback from your customers. Daily stand-ups. So if you're deploying to production every 2 weeks, that is at least 2 weeks between someone having an idea, being able to test it for 2 weeks, and then making a conclusion. It's taking you a month to test an idea. That's a very long time. And so if you say, oh, I want to optimize for, maybe I should change the theme of our website for Christmas. Yep, sounds nice. When do you need to start working on this? September. If you have this idea in December, well, you'll deliver it right in time for the new year. Yep, well, Christmas was slightly delayed this year, folks. Plans versus reality. Oh, another one. Because planning is essential, but plans never survive contact. Testing in a dev environment is kind of like planning. Works on my laptop. Works when there are no humans involved. And then suddenly, oh, what happened? Well, the Germans just came around my defense line. We had no clue what happened. That's the Maginot Line from World War II. The Germans don't really go through. Well, and a few things changed in the meat space, Everybody, all armies fight the last war. All managers plan for the last business catastrophe. Not the next downtime. Not why you're going to have problems next time. Why you had problems the last time. Just a known thing because that's what you learned from. So, well, somebody comes around out of left field and you're suddenly left with nowhere to go. Car manufacturing, well, welcome to electric cars that learn, or even better, self-driving cars. Well, I don't need to buy a car if I can just rent one. And self-driving car means I don't even have to need it. I don't need a driving license. So much easier, right? And so the roads become so much safer if everything is automated. Well, hopefully. But in general, less problems until somebody decides to cheat. Volkswagen. And then again, Darwin works. You come around and you go, everybody goes, well, who's going to survive? IBM, HP, Apple? How far? They're big companies, right? And then you can say, well, probably they'll be dead in the next 10 years, 15 years, because they can't adapt fast enough. Who's responding fast? Startups. Because they don't have a choice. Amazon, Google, Facebook, all respond really, really fast. How long did it take for Facebook to say, well, let people put up an image of the flag of France on their face? Because they have done this before. And the first time they did this probably took them time, but it can always be done again and again with a different image. But you have to be able to adapt really fast. What happens if you decide to go to tomorrow a large market like, say, India or China, and then it turns out that the people there don't have fast connectivity? And your homepage is all of 9 megs, or like some magazines, 80 megabytes. 80 megabytes, I don't know who likes that for a mobile web page. Not even the desktop, mobile. 70 megabytes of that is advertising. I don't want it. I have to pay for that data and never going there. But if you can't respond fast, you're dead in the water. How do you respond fast? You have to be able to say, I need production metrics for this. Doesn't matter where else your metrics come from. Oh, right. Testing versus reality. A nice stable environment in test, in dev, well, dev less so. But people say, well, we need testing so that we can do a stable integration build and all that. Yeah. Also, I'm not a big fan of compiled languages for this. They generally do not work very well in a very dynamic environment. You want to be able to optimize for change. And compiled applications just take too long to be able to deploy to production. You can make it work, but not so well. And at some point, you say, well, the added performance benefits are worth it. But there's quite a bit of time between where people are and where the performance benefits are. Premature optimization is the root of all evil. And that is, again, a thing that you can choose to distinguish between production and, well, it's ready. We can probably go, it's going to cost me more to rewrite my application or not. If you're doing testing in production, rewriting an application is perfectly normal. There are no humans in testing, well, or no, mostly not. There's some involvement, but, well, it's all automated. Here's a bunch of scripts that you throw, and you say, well, all my requests work, my database queries work, I'm getting expected responses. And then somebody puts in bad data, and everything blows up. Oh, but then again, that's not checked in testing, usually, because that's the problem of some other subsystem, right? If nobody can put in bad data, well, mostly. But sometimes requirements change. They're communicated to one team, not the other. Large teams, painful. Low latency, potentially high latency. This is a fun one, because I don't know of anybody who's been able to change the speed of light yet. So I hear there was a startup back somewhere in 99 whose entire business model was predicated on being able to deliver data faster than the speed of light allowed. And they got funding. So people here may not notice so much, but you go outside Europe to some place with poor connectivity and I can't read my mail. Why? Because it's not I have 3G connectivity. I just have no bandwidth past that. It's latency. Well, one satellite hop will kill you on a very large TCP transaction. And the other thing with testing, people tend to just take, oh, here's my production data set, and then I'm going to replicate that into testing or dev or other environments and shrink it down. So we don't have to waste so much space. It's shared databases. We don't want to keep all that data there. SQL does not behave the same way if your data set changes. Query plans will change depending on the size of data. So what are you developing? What are you testing against? Well, who the hell knows? Your entire test is meaningless. If you want more fun rants about that, this guy, Theo Schnausnagel of Circonus, has a few blog posts about it, about how people end up with meaningless maths, especially about averages and percentiles. Whew, that's a different talk, and I will let him in. It's a fairly entertaining read. Why do people do this? Oh, wait. It's a nice number, but it doesn't mean anything, sort of thing. Oh, users. This I love, because as a friend of mine put it, users will user. In response to someone asking for something very dumb. As in, I want to delete this box, but I still want to have it available in the CMDB. What? Or they make mistakes. How many people have never broken production? Anyone? No? Good. They come up with different requirements. Or as the software development world calls it, scope creep. Oh, well, we have a system that does this. Can I get this one additional checkbox? No. Well, maybe. Or they just change the world your system is working in. Sure, we were deploying this to Intel boxes, but tomorrow we are going to be deploying to Sun. Good luck. Or Well, we were on Oracle, but we need to move to Postgres. World changes. Or we used to have to support only IE6, but IE6 is no longer supported. Help! Enterprise software. We hate it. Risk management, oh, fun. Approach one. You've basically waterfall, or pretty much anybody who solved a technical problem. This is a fixed size of problem. We can test a lot, we release stable code, and we know that because we have sufficient tests and everything, this will work. And then you avoid changing a working system. It's been deployed to production, it works, it's stable. Let's try and avoid making changes. That's pretty much enterprise software, right? And then you have this other crazy option, which is you accept that you have an ill-defined problem. You don't know what the hell is going on because, well, nobody knows why people buy stuff other than the fact that they need it. But if you ask someone, why did they choose to buy this product or that product? Well, one looked better to me, or I'd heard of the brand name, or something. You don't know. Hell, it's one of those things that is actively researched and we still don't know. So you have to iterate rapidly. You have to figure out a lot of A/B testing, lots of small tests. So at Booking, we were running about 200 to 300 tests concurrently, and with overlap, so you could end up being in a single set of maybe 8 or 10 experiments at any given time. And each of those 8 experiments would impact something different or overlapping, and you could measure the impact of each. So you can make a large number of small changes, deploy each change individually, and test. And then you have to say, well, how the hell do I know what each change is doing? So you basically have to start tracking metrics from within your application. You have to instrument your application. It has to be not only be debuggable, everything, it must generate its own metrics. You do not want to pull metrics from applications because you don't know what you're going to pull. You ideally want the application to generate an entire event object that says, I got a request at this time, I got with this data from this IP or whatever else, and a single session ID that is trackable throughout your entire infrastructure. So tomorrow, if someone says, what did this particular user do? Here was the session ID. Here are all their sessions around that time. Easy enough to track, and you can then say, well, this is what we know about this particular user session at this time. You know what they did, you know which pages they hit, you know how big the request was, you know how big the response size was. We have seen fun rollouts where your response size suddenly blows up. And then you go, what the fuck? Why are we running out of bandwidth? Oh crap, somebody broke the compression, so we are not serving minified JS any longer. Problems. Or, oh, we changed the default size of the image to be shown from whatever, 320 into whatever to doubling that, and the image suddenly became a lot bigger. Or we changed default image formats. And you test all these changes, see what people respond to. How many people think your boss would be happy if you were to say, I want to buy twice the hardware next year? Well, maybe they will be happy, maybe not, but most of them are going to go, huh? Why the hell do you want to do that? Well, we deployed the system, it's a bit slow, it's unoptimized, but it has driven up profits 10 times. And they'll go, oh, you only want to double my cost, fixed costs, and you want to give me 10 times the profit? Sure, have the money. And we can spend the next year optimizing that, so the year after that you don't have to. But this sort of trade-off is something that we have to figure out before we ask for more hardware. And how do you know this? Well, you have to follow the money. Is this hardware, if I'm putting money into a system, is it going to give me more money? Is it going to save me money? Buying 2 smaller boxes versus 1, using MongoDB instead of a relational database. Well, okay, it's still Mongo. YOLO. There is no what if for software breaks. Or as we put it, hardware will eventually fail, software will eventually work. You fix fast, but maybe. There are some people who love to say, well, this site is broken. We are off by 1 pixel. Has it affected my growth? Has it affected anything? No. Page views are consistent. People are still buying. We don't care. It doesn't look perfect to the designer. On the other hand, maybe you want to really fix this because somebody ran an experiment that said, well, we'll have light text on a dark background. And someone said, well, we'll have a light background. And then suddenly people are not able to buy because they can't read anything. White text, white background. I'm not sure that works out well for people, but hey, errors happen. Quick fix, because it's scoped to an experiment. When you're doing testing in production, you do not do a wholesale forklift update ever. You update software, but you say, I'm rolling this change out as an experiment to a certain set of people. You can do this by rolling out a canary deploy. You can do this by rolling it out within your AB framework or within your multi-arm bandwidth test framework. It helps. And then you say, well, I'm going to give this to only 1% or 0.5% of whatever of my users grow up slowly. Which means that even if you have a problem, it doesn't kill the rest of your systems. Well, if you're lucky, it doesn't. I've seen one particular fun bug which was in very well-tested old code that was triggered by a code change that made a difference, that broke a set of assumptions. It expanded network IP addresses into from the block to every IP in the block, and well, stored that in memcached. Unhappily, the production network had a /8 net mask. Out of memory. There's only so much memory there's only so much you can shove into a cache. That was a hard one to debug. And if you're going to you don't care about doing it right the first time. You don't care about duplicating code. You don't necessarily care about saying, don't repeat yourself. It's cheaper to copy paste code, edit it to do what you want, roll it into production. Does it work? Yep, let's fix this. If not, doesn't matter. The standard rules for software development do not apply. Your business process for handling failure, most businesses will already have those. Your boss is not going to be unhappy if things break, and they know that this sort of break is a possibility. Because then they can have a process that will fix it for them. Your car order didn't come through look at cafes, right? Often enough, their point of sale systems break down and they go, well, okay, let's just do it on pen and paper. That is fairly reliable. But you have a process that works. If you didn't have that, you'd be dead. Oops, did I? Oh. Right. So the lifetime of code, that's another metric that people love because when they're engineering code, they tend to over-engineer it. And if you're testing in production, well, let's take this code, throw it into production, works. No, that doesn't work. It made no change. It's losing us money. Let's get rid of it. Deleting code is not a problem. It's always a nice thing to do, cleaning up. But you can just delete code, and if you are using a version control system, you don't worry about losing anything useful. Oh, that was important. Well, let's reverse that. Just revert the commit. How fast can you do that? Well, git revert is pretty quick. Most code, front-end code particularly, hours, days. Booking had a 1 gig code base, and the average lifetime of new code was 3 days. In 3 days, a lot of your code would just go away. If not, the next big thing was, where am I? 15 days worth of code, because that was usually how long an experiment would run. Some code would run for months, after which the application would have to be rewritten and thrown away because scaling. And if you're doubling in size, you're always solving new problems. If you're growing at 40, 50% even, you basically have to throw away all your old code because the algorithms no longer work. If you're lucky, they do, but sometimes it just becomes, well, we have an O(n) square algorithm and it doesn't work. Or we need to shard data, we need to rewrite the application because now we need the raw performance, and now it's a well-defined operations problem or a dev problem. And then you have core libraries or really core services like authentication and database interfaces. Those things tend to stay around for years and years on end. Those need to be very well written, very well tested. But if you don't know what your code is going to do, I would put it in the first category most of the time. Push your code out, see what your users say about it. If they don't like it, roll back. Doesn't hurt. It is safe. Let me reiterate this because I've heard a lot of people crib. It is safe to delete code if you're using version control. Doesn't matter what. If you aren't, well, you should be. Event processing, well, he's already described events, so I will not explain in great detail what that event ends up looking like. But it is basically a track of what happened on the system. Somebody comes, hits a web page, an event is generated. You add in what methods were called, all the information that you got from the client browser, how long each method took, whatever else, some SQL query that was triggered, what parameters were passed to it, what if you're somebody, it's a search page, what searches were triggered. Do not rely on web logs. This comes from the application. And then your business analyst guys can go and say, oh, we have so much information about what people are doing in production. They have their own tools. They generate their own metrics. You can grab metrics from those things and say, here's a bunch of graphs with what we are doing in real time. And then suddenly your feedback loop goes from, well, we get a mail once a day about how we are doing well, or we know about how well the software is doing because we hear a quarterly business update for the stock market. Yeah, not so much. If you can detect your bad code rollouts really fast, you can pretty much revert them as well, really fast. So your downtime blip goes, and it just works. Well, that was just a slight blip. Or, well, it was down and we didn't know until users started complaining about it. You want to know well before the users do that there is a problem. Because people will detect there is a problem, hit refresh, oh, it doesn't work. Well, I'm going to a competitor. Spotify is lucky that way. Not enough competitors. But if you're not in that category, if you have internal users, well, they can't go anywhere else either, but then your help desk is going to come bitching at you. Okay, so I was going to put up a couple of slides about this, but these 2 pages have way too much information to digest into 1 or 2 slides. That would be at least a decent day's worth of talk on that. So TMI, you'll have to read this. Monitoring, alerting, process your events to generate graphs. Events feed into BI, feeds into monitoring, feeds into dev feedback, feeds into for everyone. Events are what you are your feedback stream, and then you have to drink from the fire hose. Riemann, again, a shout out. It works. I have had the same issues with as Spotify did. People don't like writing Lisp. I don't know why. I do. It's easy. Hey, I like weird languages. I like Perl. And Lisp and SQL. SQL's easy. But then again, I'm also one of those people who hates writing Java, so yeah. Generate graphs is close to real time. You know what is happening now, not 5 minutes later, not 10 minutes. If your graphs are lagging by 10 minutes, you're flying blind for 10 minutes. Metrics are your stream of visibility. If you don't have metrics visible, well, you're flying blind. Don't do anything at that point. Wait for that system to become stable. Because if you can't see what is happening, you do not know whether you're doing a good thing or a bad thing. Doing nothing is usually the safe option. And an image, and if you can isolate each change, wrap every experiment in a flag, feature flag, you can turn it on, turn it off. Your metrics about that a test, then get flagged, come along with a flag that says it was part of this experiment. So even if you have 200 experiments running, you can analyze them each separately, independently, or as a combination. So you can just say, oh, if we have this experiment and this experiment working, it works out. I don't know if you've seen one of these, if you've booked a hotel with that booking that allows you to do pay later instead of the advance payment stuff. But if you have, they put up a flag there that says, I want to be able to manage my own booking, and I'm willing to receive free refunds if I cancel later, blah, something. That flag is documented in the right on the description of the room, and there's also a checkbox that appears on top. Adding that checkbox was just a random developer idea, and it reduced customer calls by about 25%. Massive, massive change, because people were calling in to get bookings modified, and they went, oh, I can manage my own booking now. Excellent. They could. They just didn't know it. So small change, 30 minutes of work, 25 minutes cut in customer calls. Customer service is suddenly happier, and everybody is happier because your waiting calls have gone down. How can you win? Big win. Production test. Oh, questions? Anyone? Oh, there we go.
So what you're describing is the agile approach to software development, as far as I can see?
No. This is agile approach to business, not just software development.
Okay.
So, because even when people speak about agile software development, they expect to say, well, we have all these user stories and stuff. This is not quite software development. This is more serverware development, whether you're doing microservices or not. I don't spend time in testing, and a lot of people say you should do a lot of unit testing and validation before you deploy. I'm saying minimal testing in dev, push it out to prod, and see what happens.
Yeah, so it is data-driven, basically?
Yeah.
What we have found out in a different context, is probably something everybody knows, is that correlation does not imply causality.
Yes.
So you can have data supporting your case, but caused by something completely different. So the question is, how long do you need to test and before actually your case is supported?
So you need to get a statistically significant number of reports, and if your and that depends on how often your experiment is actually seen. I would go ask a statistician for the details based on your specific question. I know enough statistics to be dangerous, but not enough to give you an authoritative answer.
Okay,
but if you get a few % of your viewers to say, well, a positive or a negative response, it helps.
Yeah. On the other hand, if you're going to be a good scientist, you're only running one experiment at once and looking at the changes, which, of course, extremely limits your ability to ship new features, right?
Well, no, you can have one if you're doing an experiment on a web page, you can have one experiment that changes something on the top, something that changes something in the middle, and a combination of each. So you can have stuff where you run only one experiment, show it to a certain number of customers. Another experiment only goes to a certain number of customers, and then some people get the combination, some people get the base.
But then you have to be sufficiently confident that they do not influence each other adversely.
Yes, yes, and that is something that you have to validate by making sure that those experiments do not actually collide. Or actually, half the time you don't care about the specific cause of it. If it works, it's good enough, right? And 1% or 2% increase in sales, good enough. Or if you're booking, you basically go and say, well, 1% not good enough. You need to be doing about 10 or 15%.
Okay, thanks.
But, yeah, basically you have to go ask a data scientist this question. I'm not good enough to answer this one yet. Anybody else? No one? Given a trollish topic like this?
Yeah. Hey, how do you keep your feedback loops short? Because when something breaks, they first go to support. Support then has something like, I can't pay on your site.
then they go to infrastructure, ask, is the server down? And then in the end, it turns out the user does not have a keyboard attached. And
well, yeah, but half the time, if you're in production, you're looking at metrics. So you can just go and say, well, we are missing out on people. We see people coming to this page and then dropping out. So a payment system glitch, even if you're not seeing 500 errors or errors spike, you can just go and say, well, we are seeing the normal number of people coming in, but the number of people actually making a payment has dropped. Something is wrong. And pretty much you define a few critical business metrics that you say, well, sales numbers, page views, and you don't have to have a dollar value out there. Just say, we have 1 sale per second or 10 sales per second or whatever, or 1 sale per minute. And then you track those things religiously all the time. Put up a big TV screen on the wall and keep rotating through those graphs. 8 or 10 KPIs max. I prefer maybe 3 or 4. And say, if these metrics are in good shape, the overall operation is in good shape. We don't have to worry. If those metrics start going wrong, all hands on deck, ship is sinking. So your metrics, if you know what your KPIs are, and those you can define right from the top of the business level, saying, this is what we want to track. Gives you extremely useful information in terms of saying, oh, here's my feedback loop. But before the customer is calling in, before helpdesk calls you, you can go and say, oh, something is going wrong here. You can also have it helps if you have, say, an internal IRC, IAM Jabber server, whatever, that a lot of people are allowed access to. Because then a user can simply just go and complain in the helpdesk room and, oh, I have a problem, blah. Lodging a ticket, let the helpdesk do that. And then you go, okay, that's odd. Or customer service hops into your Jabber channel and says, we have a lot of customers complaining that they cannot book rooms. This was New Year's Eve. Well, this was New Year's Day. And the bug was that someone had fixed the date-time routines, and the clocks were in a different time zone. So when the clocks switched to the new year, all availability for the old year was basically 0, and the US is later in the day. So US customers couldn't do bookings on a very big sales day. So customer service calls us and goes, yep, we have a problem. Look at it, oh crap. Here's the graph difference. Grouse up developers, roll a fix into production. Got a call at 12:30, production was fixed at 1. So that's how fast you can do it if you have a system that is set up for production deployments all the time. Or on the other hand, my current place had a complaint last year where they found a bug in a Apache rewrite rule. The bug fix, from detection to actual fix, 1 hour. Getting it into production, 6 weeks. Why? Because it spent time in test, it spent time in acceptance, it spent time in performance testing, and then finally, after going through all those validation stages, it went into production. Because no one wants to do an emergency rollout, right? So you make sure that no rollout is ever an emergency rollout. Even if you do it at 4 o'clock in the morning with no one else around. We used to have a developer who did that. At 4 o'clock in the morning, yeah, well, I've just finished writing code. Let me push this into production before I go to bed. Yeah, well, you push it into production, you make sure that there are no errors being generated, nothing is broken. If everything is good for half an hour, you're probably good to go to bed. No, that was the thing. It wasn't. His usual problems were that he would make a database level code change, and then that would show up in a bug somewhere 3 weeks down the line in another development team. And they would go, what changed here? Oh, I fixed this routine so that it would actually do the right thing, and you no longer need to fix stuff on your side. Oh, we can get rid of some more code. Easy fixes, but no complexity at all. And worst case scenario, just roll back.
So what kind of organizational requirements do you see necessary for having an organization where failing is part of business?
Well, I mean, I would just say that people who are willing to accept that they are doing product development and not manufacturing, which is why that book out there is, I put that book image there. If people have read the goal, the principles of product development flow is roughly the analogous thing for product development. It's mostly research. You need to run enough experiments to be learning something, and you need to be able to say, well, not all experiments are going to be successful. If you're doing R&D, not everything works. But then you find that one thing that works, and then you suddenly have a whole new industry. Light bulbs, 10,000 tests, one of them succeeded, and that was good enough, right? At least that's the way the story goes. So people have to realize that they are, in software at least, they're not doing manufacturing. The analogy is software product development, or it's product development. So you have to go and test. I think I have a link there. Oops, okay. Fine. So there's a different, so there's a KPN paper out there where they ended up saying, we have an application, we ended up having to test an application in production because we didn't know what our customers wanted. And this is a mobile company which is writing a custom application. And then they found out a whole bunch of interesting bugs that you would never think about. Like, oh, people are trying to log in and it doesn't work. Oh, because they're using the site password instead of a special key. Maybe we should have that work better. That sort of thing. So if you have that mindset throughout the organization, it works. It helps to have blameless culture. Well, that's pretty much a necessity because shit is going to happen, and if you start cursing out people instead of just saying, okay, what can we learn from this? You are dead in the water because nobody is going to be willing to accept blame because then they go and say, you have a lot of testing, and you want to have a bunch of people who are willing to take smaller risks. Rather than saying, let's deliver perfect software, let's deliver something that is good enough, is a mindset that has to pervade through the entire organization. It's not just limited to development and IT. It has to be throughout, because if you cannot convince your managers that this is a better option, better way of doing things, it's not going to fly at all, because then any bug is going to be, you're doing things wrong, roll it back. This is an organizational process change. You have to build your organization from the ground up, or make sure that people are willing to say, let's try this and see. At least for long enough until you can prove that it works or doesn't work. Steve Yege had an excellent post about this from back in, I think, 2003, 2004. If you want to search for it, the term serveware, which he was trying to popularize, it's a very long read, though. But again, it's a Steve Yege blog post. For those of you who don't know him, he likes to write really long rants.
As a follow-up to Martin Palm's question about the corporate culture, don't you also have to have people knowing what they're doing all the way through, which is a strong requirement, in my opinion, because you need to know what you are going to influence by every single line of code, of change. So you know what you're monitoring.
Right, but at that point, you're also, if you don't have people who know what they're doing, then you had better be investing time in training them. It's not like any one of us knows everything. So you have to be willing to train people and help them adjust into a culture where they can take these risks and learn. And but if you have people who don't know what they're doing and you let them loose on production, well, it's a risk. But usually you start off by saying, having people make really small changes, and then they can grow into making bigger changes. So you change one line of code. Oh, here, this text file, change this to this. This is what we expect it to change. You can pair program initially with someone senior, but that's again how you introduce people into the organization as well. So you will say, oh, these are the corporate standards here. This is how we do testing. This is what we expect to see. Good enough. Hell, it is harder to train people to write good commit messages than to write code that works. If you're a semi-competent software developer, you will be able to write code that works. You might not be the fastest person in the block, but that's fine. No one says you have to write code faster, as long as it gets to production fast enough. Perfection is not a requirement. It has to be good enough. You have duplicated code, fine, because you are going to end up rewriting this code. You can duplicate code, you don't have to be perfect. That's what I'm saying. You don't need to know all the details of what will be impacted. It is a risk the organization is willing to take. And you can then say, well, we do not want a monolithic app. How do you reduce risk? Well, let's make it a microservice. Split into services, make it a microservice, whatever. Or the best part of it is, well, why are we writing code to do this? Let's not. Because you don't have to, not all problems necessarily need a code solution. You can always find an alternative way of doing things. And if you can find a way that doesn't need code to run on production, well, there's nothing as fast as code that doesn't exist. I mean, I've literally seen new juniors coming into an organization and doing a code deploy on like day 3 or day 4. And we go, well, that's normal. Oh, this is a new person. What does they want? Why the hell? And then we got this new guy at Booking who was getting root access to a bunch of systems, and we were like, hang on, this is not acceptable. Why is this guy getting root when he's new? Otherwise, culture is, oh, you need access to a box? Here, have access to production, except a certain set of boxes. You want to debug in production? Go for it. It's just a testing network anyway. Anyone else? I think we have time.
Yeah, we have 10 minutes left, so otherwise,
This coffee.
coffee break. And yeah, thank you, Devdas.
Thank you.
Nice to have you here.